In this video, we'll look at question 46 from the 2016 paper.
This question is about a collision of two balls. One is 4 kilos, the other is 2 kilos, and the bigger ball is approaching the smaller ball at a speed of 10 meters per second, while the other one is stationary. And just after the collision, we know that the smaller ball flies off at a speed of 10 meters per second to the right, and the other ball also probably moves, because we are asked to find the speed, v, at which it does so, and also the energy lost during this collision. So, first of all, we know that energy is not conserved, or we guess, because otherwise they would probably not ask about how much energy was lost. And at the same time, as usual, momentum must be conserved. And in the exam, if we are short on time, this question we could solve much faster than conventionally, just by saying that in the beginning there is positive momentum 40, 4 times 10, to the right, and the blue ball after the collision only has 2 times, it's 20 to the right. That means in order for momentum to be conserved, the red ball after the collision also has to have some momentum to the right, i.e. its speed must be to the right. And the only such option given in the exam are the last two, in both of which speed v is 5 meters per second, so it must be that. So we got that piece of information kind of for free, and the only thing that's left now is to calculate the energy which was lost during this collision. And that is defined as the energy which we had before, minus the energy we are left with after the collision. And these energies are all just kinetic energies of the balls. There's no other potential or, well, any other energies or changes in energies involved in this. So we can use our definition of kinetic energy as half mv squared with the mass and speed, and when we plug our numbers into this formula, to the combination of the two, we see that the energy before is just the energy of the red ball, this one is not moving, minus the energy of this ball plus that ball. And numerically, it gives us 50 joules, which is our final answer, and in the exam, it was option E.